Hello and welcome to my class. I'm Grolin Annalisi from ThinkMo Education. I'm currently a Cisco Technology lecturer. If you like my video, welcome to my study group. Or contact my teaching assistant. WhatsApp account is +6 583444290. Today's topic is EIGRP experiments and OSPF. In the last lesson we learned some configuration. We are done with the announcement of EIGRP. Then finally let R1 learn the root of R4. In the last class, I let everyone observe. How many roots can R1 go to 4.4.4.4 now? We also talked about topology tables and routing tables, etc. If now there are 2 roots to go, will these 2 lines appear in the topology table? If it does not appear in the table, what is the reason? I also leave a question for you to think about. That is, if I want the following line also appear in the topology table, what should I do? Here are some small questions I left for you in the last class. So let's go through them together in this lesson. Before class, I configured the address. First review the final configuration content of the last lesson. I redeclare. And then go on. Because it's been a week since the last class, I think you may have forgotten these configurations. So do a review. Otherwise, I'm worried that you won't understand what I'm going to say next, including OSPF that will be discussed in the second half of the class. It is similar to the configuration of EIGRP. All configuration commands are similar. Everyone can feel it too. Okay. We officially start class. First here on R1. Create an as number in EIGRP. That is, I will now enter router EIGRP. Here is an as number. We still use 100. In the last lesson we used 100. Enter the routing view of EIGRP. To turn off automatic summarization afterwards. Then we now, after creating the entire EIGRP autonomous system, we're about to start building neighbors. The way to create neighbors is, for example, declare the directly connected network segment between R1 and R2. Then they establish a neighbor relationship with each other. Network 12.1.1.0. Then the directly connected network segment between R1 and R3 should also be declared. Is 13.1.1.0. Okay. This is the R1 devices. So now that we're done announcing, if now behind R1, there are other network segment information, I can also complete the declaration. But now R1 only has 2 direct connections. So the configuration of R1 is done. Let's look at R2 next. R2 is the same. I go inside R2. Be sure to create EIGRP first. Also 100. Turn off automatic summarization after. Also complete the declaration. Declare a direct connection between R2 and R1. Network 12.1.1.0. 0.0.0.255. It reminds us, I have now found a neighbor. That is 12.1.1.1 of the other party. We have seen. Then we configure the next. We will also declare the directly connected network segments of R2 and R4. 24.1.1.0. This is the configuration of R2. Then R3 is the same. Let's do it simply. The first must be to create EIGRP 100. Then network 24.1.1.0. 34.1.1.0. This is the configuration of R3. Oh, I made a mistake. It should be this device. Then I need to reconfigure again. I thought it was configured with R4. I now want to cancel the two announcements just now. One is 24.1.1.0. But 34.1.1.0 does not need to be cancelled. Because R3 itself has this network segment. Then we have to redeclare 12.1.1.0. 0.0.0.255. This is the configuration of R3. Next is R4. First of all the same. iGroup 100. Then you have to manually turn off the automatic summarization. Network 24.1.1.0. This is the directly connected network segment. Between R4 and R2. Then it is the directly connected network segment. Between R4 and R3. 0.0.0.255. Okay. We are done now. For R4. There is also a loopback port. We're going to declare the loopback port as well. Let R1, R2, and R3 all learn. Network 4.4.4.4. This is the last one. 0.0.0.0. Okay. We are done. We can come to R4 now. After finishing R4. Let's focus on R1. First let's look at the neighbor table. In the last class, we talked about 3 tables. They are more critical. We are now here at R1. Check to see if it has learned the root 4.4.4.4. Show IPEIGRP neighbors. For now. Let's first look at the neighbors. How many neighbors will there be now? The neighbors of R1 and R3 are not established now. Let's also check here in R2. Show IPEIGRP neighbors. R2 is correct here. Why is R3 not established here? Let's check. 34.1.1.4. It should be that the address configuration of R3 is wrong. Some addresses I assigned before class. I need to check. The left interface of R3 is S10. 13.1.1.3. No problem. The right interface is 34.1.1.3. No problem. I don't seem to have announced it on R3. Then I declare here. Network 13.1.1.0. 0.0.0.255. I'm done now. It pops up a log. I'll recheck it here. Show IPEIGRP neighbors. Already learned. When it now learns, we should see the same effect on R1. That is, if we look at it now on R1, will be 2. After checking now, let's interpret this representation. For R1. Now we are looking at a neighbor table. Well, I told you before. This is the address of the interface that R1 sees locally. That is, this is when it and the peer are establishing. Peer interface address. So R1 local is 0.1. So, this 0.3 represents R3. This 0.2 represents R2. This is the relation